We are now starting the International Roundtable on Energy Storage Systems, and with that, I would like to welcome all of you. This will be a very fruitful event, as I can see. And if I tell you the background story of this event, actually, it was first came from Dr. Amitav Bandyopadhyay, from the Director General of the Non-Aligned Movement Science and Technology Center in New Delhi. And together, the DSI, the Department of Science and Innovation, South Africa, Mr. Selby Modiba, he is our colleague, so we had a long discussion. And actually, this is a precursor to a much bigger event, most probably in April 2023, a physical event. Dr. Amitav will shed more light on that later. And that will also be on energy storage systems. So most probably it will be held in South Africa, so that you will be able to visit this beautiful country and enjoy that conference, so that the idea of this conference, this roundtable, is to take an initiative for this bigger event. And there are key partners, four key partners of this event: the Non-Aligned Movement Science and Technology Center in New Delhi, the DSI South Africa, the University of Witwatersrand, and the Energy Storage Chapter of SAIEE. I think I have to introduce myself with that. I'm Chandima Gomez, a distinguished professor at the University of Witwatersrand, and also I'm the chairman of the Energy Storage Chapter of SAIEE South Africa, so that I'm representing two entities of this partnership, the WITS University and SAIEE Energy Storage Chapter. And the Energy Storage Chapter is actually formed in 2020 with the intention of promoting energy storage related research, industrial aspects, technology, guidelines, policies, and the entire picture of this emerging sector, which will play a huge role in the future. And all of you are invited to become a member of this energy storage chapter, irrespective of the country that you are living, so that you can join all our events. And the membership is free. I will post it on the chat column while the program is going ahead. So with that, let me invite the next speaker, Dr. Amitav Bandyopadhyay, the Director General of the Non-Aligned Movement Science and Technology Center. Actually, I have a long term interaction, cooperation with the NAM Center. It played a huge part of my career as well. So please, over to you, Dr. Amitav Bandyopadhyay.
Good afternoon, Professor Gomes, and a good day to all of you. Professor Gomes, Ms. Joanne Dean, Vice Chair of the Energy Storage Chapter, South African Institute of Electrical Engineers. My good friend, Mr. Selby Modiba, Deputy Director, Multilateral Cooperation Department of Science and Innovation. special invitees and local participants from South Africa, esteemed resource persons, and other participants from various NAM and other developing countries, distinguished guests, colleagues, and friends. It is an honor and privilege for me today to welcome you all and address this inaugural session of this one-day international roundtable on energy storage system, which is being organized by the NAM Center in partnership with the Center of Excellence on High Voltage Engineering with South Africa, Department of Science and Innovation, our focal point in South Africa, and the Energy Storage Chapter, South African Institute of Electrical Engineers. It is my pleasure to inform you that the South Africa has been one of the most active members of the NAM Center for many, many years. The Department of Science and Innovation, the focal point, as I have mentioned, in South Africa, has nominated a very large number of scientists, experts, and professionals from various departments, academic and research institutions for their participation in the scientific activities organized by the center. Moreover, several young scientists from South Africa have been benefited by availing the fellowships offered by the center in the centers of excellence in various countries. Now, marching from black energy to a world of green energy especially requires energy storage systems that could hold sizable quantity of energy for a reasonably long time and to maximize the usage of energy produced from renewable sources. Most renewable sources are holds great potential for the developing countries in which renewable energy dominates new additions and over the years gradually may overtake the other sources of electricity. Again, energy storage system comes in various forms such as electrochemical, kinetic, electromagnetic, chemical and thermal, and it also uses fuel cells, batteries, capacitors, liquid and compressed air, and any other forms. Thus, there is a need to accelerate advanced research on inventing new, innovative, and cost-effective energy storage systems. In view of the above, this roundtable aims to provide the participants with an understanding of importance of energy storage systems, such as the latest and cost-effective technological developments of energy storage systems, the applications and benefits of energy storage system, including overcoming several energy storage barriers and addressing the key challenges. For all those who are not familiar with the Center for Science and Technology of the Non-Aligned and Other Developing Countries, in short, the NAM is an intergovernmental organization. Some disturbance.
Can you please mute your mics, especially those who are joining?
Okay, now it's.
I think now it's okay. You can go ahead. Dr. Amitav, your mic is muted. Dr. Amitav, you have to unmute your mic.
Yeah,
you
I have done
muted
that.
your mic as well. Oh.
Okay, for those who are not much familiar, the Center for Science and Technology of the Non-Aligned and Other Developing Countries, in short, we call it a NAM-SNT Center, is an intergovernmental organization which was set up in 1989 in New Delhi, India, in pursuance of the recommendations of various NAM summits. It is a diplomatic entity and has 47 member countries from African, Middle Eastern, Asian, Latin American, and European region. The center aims at promoting South-South cooperation in science and With this, yeah, it is unmuted. Okay. The center aims at promoting South-South cooperation in science and technology for collective self-reliance of the developing countries with a special focus on sustainable development goals. In order to achieve its objectives, the center has succeeded in providing a platform for scientists, technologists, and other professionals in NAM and other developing countries to exchange ideas and share knowledge among like-minded people through their participation in large number of international workshops, roundtables, and training courses on various S&T themes and topics of interest. The center has been undertaking collaborating S&T projects and offering short-term fellowships as well. The center has also brought out 90 publications so far. I'm extremely delighted to mention that the NAM Center has recently brought out its first monograph titled Lightning, Science, Engineering, and Economic Implications for the Developing Countries, which has been conceptualized and edited by Professor Chandima Gomes and is published by Springer Nature Singapore. Let me add that we strongly believe in the merits of partnership and equitable duties and privileges for all the stakeholders for the success of any program. That is why the NAM Center jointly with its partners have invited over 275 subject experts and professionals from more than 25 countries for their participation in this roundtable. I'm confident that this roundtable will prove to be a great success towards providing a platform for networking, knowledge sharing, and exchange of ideas among the experts, professionals, and policymakers in the area of energy storage system. Once again, I would like to thank Professor Gomes, Ms. Joan Dean, Mr. Selby Modiba, various invited speakers, guests, and participants for their kind support and cooperation with the NAM S&T Center. With this, I wish all a great learning experience and knowledge sharing experience.
Okay, thank you very much, Dr. Amitava. So the next speaker, our next speaker will be Mr. Selby Modiba. But before that, may I request again, please keep your microphones and microphones muted and cameras switched off while the other speakers are speaking. Only the person who is speaking should unmute and also switch on the camera. So please welcome Mr. Selby Modiba. He is the Deputy Director of the Multilateral Cooperation of the Department of Science and Innovation of South Africa. Mr. Selby, it's over to you.
Thank you very much, Prof. Gomes, Dr. Amitava, ladies and gentlemen. Good morning, good afternoon, and good evening from all over the world where you come from. Thank you very much for the opportunity to speak. We are indeed pleased to see this event finally taking place. And we think that from the Department of Science and Innovation, within the framework of South Africa's new decadal plan for science, technology, and innovation, energy and energy storage and technologies are highlighted as a priority. And this is really due to the fact that South Africa is currently faced with energy securities or energy insecurity because of the power shortage or power cuts that we are currently experiencing. And we think that more knowledge and innovation in this area will assist us to reduce the burden on the energy supply company called Eskom, our energy utility, and more energy users or electricity users will be able to produce their own energy and store it for use later on when they need it. And we think that South Africa and many African countries, including the non-member states, are endowed with mineral resources which are used to build components of the energy storage facilities, such as the lithium-ion batteries. And as such, we should be leading the world in this area. Issues related to value chains and pricing of the energy storage facilities like the batteries, as I said, are also a challenge. And therefore, we hope this roundtable can be able to share some light on how the knowledge of this field can propel us to a more energy secure South Africa and the rest of the NAM Center member states. Thank you very much. And I wish you all a success in this very important event. Thank you.
Thank you very much, Mr. Selby Modiba. Now we are going to the first technical presentation. Before inviting the speaker, let me point out one very important aspect of this whole event. Now, Mr. Selby Modiba very clearly stated the stance or position of South Africa in this whole picture. We are having an energy crisis, I may say. It's not because South Africa does not have energy resources. It's simply because it's not properly managed. Otherwise, South Africa can provide energy to almost the entire Southern African region. So today we have a speaker from Iran. Then we have participants, a large number of participants from India, and there are few from Malaysia as well. So I just mentioned a few countries, but there are many people from other countries as well. So these countries have their own strengths in developing energy storage systems, which is a very fast growing field in industrial sector, in research fronts, and also in the policy and guidelines. So this will be a very nice platform where we all can put our ideas together and see how we can walk together with joint efforts in this field. With that, let me tell you about our interaction session. Please type your question in the chat. I'm sure that all of you know how to do it. You click the chat and then just type your question. If you're appearing with a pseudonym, then if you like, you can mention your correct name, your correct name and country if you like. So your question will be more meaningful, and during the Q&A session, we will take up all these questions. Thank you very much. And with that, we move to our first presentation. It will be delivered by Dr. Mohammad Reza Megami, one of my longtime friends from the University Putra, Malaysia. He's an academic and researcher at Al-Azhar University, Tehran in Iran. He will talk about portable system integration with large-scale solar, mass transportation for future. Megami, over to you.
Hello, good afternoon to everyone, and thank you, Prof Gomez, for inviting me for this program. Let me share my screen. Okay, Prof, do you have my screen?
Yes, we can see. Okay, great.
My name is Mohammad Reza Magami from Al-Zahra University. So today, because of the short time, I just explain a little bit about my research and my topic. I'm working on the impact of the PV penetration on the PV system, on the power system, challenges, and mitigation method by energy storage. We are working on the electrical vehicle at the moment. So this is the outline of my research. We are discussing about what is the, we will explain about the PV penetration, what is the PV penetration, voltage profile, challenges, mitigation technique, electrical vehicle, and then conclusion. So nowadays, by increasing the PV and renewable energy around the world, we need to think about the future matters we have in the grid system. So on the other hand, development of the power electronic devices and fast-acting control made it possible to integrate the large PV penetration on the grid network. So on the other hand, also by decreasing the price of the PV panel around the world during the last decade, and also support from the government has promoted the use of the power plant around the world. So integration of the PV system or solar generation also has a both positive and negative impact on the power grid, as you know about that. So what is the PV penetration? PV penetration is defined as the ratio of the nameplate of PV rating to the maximum load. Okay, so we have this three scenario. So PV penetration, in order to measure the PV penetration, we should to make sure and measure the three scenario. Peak load scenario is mean the all the load connected in the peak level and connected to the grid, and another one no load condition and contingency condition. So if we want to know how much we can integrate the PV to the grid, we cannot easily just generate the PV generation and connect to the grid. We should to make sure the best suitable allocation and the size of the PV that we want to connect to the system. So if during the peak load, during the no load, that there is no load connect to the grid, and during the contingency condition, it means some part of the grid may be disconnected and shortcut or short circuit something. So the grid should be smart to manage the power. So advantage of the PV penetration: less pollution, low maintenance, minimize the transmission losses, and reduce the stress on the PV system. So we have a lot of challenges in the PV penetration. So PV penetration or wind penetration directly depend to the climate changes. So changing in the radiation fluctuation, either for the a small period or short period or long period, affected to the generation of the PV. So this is the one of the challenges. Another one, voltage quality, which can be categorized to voltage rise, voltage imbalance, and flicker in the network. And some other challenges as well, like a harmonic of the frequency, power fluctuation in the grid, and isolating. This is all the challenging we face in the PV integration. I just very fast go to the main part, which is more important for this event for today, is how to mitigate the challenges from the PV penetration. So we have a lot of challenges that in the last slide I already explained, like a frequency, harmony, voltage violation. So we should to mitigate all these challenges. So we have previously many techniques. So like the energy storage, like previously, we have a lot of technique. I will explain later. And we have demand response program, and we can explain for the user to how to adjust the load to connect to the grid. We can control the load active or reactive power to the grid, and we can control the tap changes. So now today we want to focus on the energy storage, which is I'm working on that more deeply. So we have, as you know about that, we have different type of the energy storage. So depend to the time of the discharge and the capacity, we have a variety of the storage. So in the power network, pump storage, which is more popular around the world, and we have a lot of projects not only in South Africa but around the world. So battery also, we one of the best option at the moment in the world because of the time of discharge, and we can very fast use the storage energy as electrical to the grid and can return to the grid. So this is the thing that today I just focus on the battery, and we want to talk about one type of the battery is electrical vehicle. So one more time before that we go to electrical vehicle. Where is the best place to integrate the PV is important for us. So we cannot connect the EV vehicle to the grid. We should to find which part of the network and grid is necessary we integrate the e-vehicle. So what before that we should to make sure that how much we can penetration from the PV or wind to the grid. So this is just imagine this is the substation. We have in the substation we have a lot of feeder. This is one of the feeder, like normal feeder. The house connected or the commercial user connected to the feeders, but in the different distances from the substation. But this is the or design. We want to know where we should to connect the PV as a rooftop or large scale PV penetration. The thing we should do important to consider is voltage level. We should to make sure the voltage level should be within the range, within the acceptable range. Okay, so if we increase the PV penetration more than standard, more than the maximum, then we have the violation maybe up or down. We should to make sure about that. Okay, this is a one typical network from the Iran. This is one that come from the one substation. We have a lot of feeders, and for each feeder we integrate the 10 kilowatt PV penetration for the rooftop. Which means for a specific location we have around 100 house, and for top of the roof of each house we integrate and we can calculate the 10 kilowatt. So we see in this feeder, especially these houses, we have a violation for the 10 kilowatt. So we should to make sure when we increase the PV, for example, for 10 to 15 kilowatt or to 20 kilowatt, we should to make sure that all the feeders within the range and there is no violation on the network. So if some violation happens, we can adjust, we can manage our violation part. So this is the one of the simulation. This is before PV penetration, show that how much during the day. And this is if you see this one for all the houses for 100 houses we just simulated, and you can see during this time and this particular house is violated. So by increasing also 10 kilowatt or 15 kilowatt, still some part is violated. So for this part we want to think about it. We can integrate with the energy storage or battery or something like that to mitigate the challenges from this part. So this is the aim of this study. So shifting the load from the on-peak to off-peak and minimizing the energy storage. Okay, so this shape show exactly what we want to do. So in the morning we have the extra generation from the solar generation or wind generation. We want to shift to during the peak time. So maybe by battery or another type of the storage. So this is the aim, to shift from the peak load to on-peak load. So, okay, at the moment we have a variety of the electrical vehicle, and the size, the capacity of the size between at the moment 400 kilowatt hour until 100 kilowatt hour, which is good potential for the small storage. Okay, so this is our system, this is our model, this is a PV. We can connect it to the DC bus by converter, DC to DC converter, and also include the battery. And this is the station for the EV vehicle that can connect to the network. So from here, depend on time and use, we can connect to the grid. We can sell to grid, we can buy from the grid, and it depends to the strategy. So this one to show that the flow chart. So the car is here, and this is the battery. The generation can be from the solar and wind for all the alternative energy sources. So during the day, we can store the energy inside the car. When we have the extra generation from the solar or wind, we can, or from the grid, we can store in the car. Then during the evening and night, return to the grid. So we are peak shaving normal load profile like this, and we are trying to shift the picked down from this study. Okay, this is our control system that we have a lot of switch for each component and each part of the system, and for each part we have the relay that we, or control management or management part, we controlling our system. Okay, this is the graph. If you see here, the yellow, the orange color is generation from the solar, and during the day from the 6 to 8 p.m., 6 p.m., and the battery store or vehicle store the energy, and during the night return to the grid. Okay. So now the distribution company and the government must support the customer. So until now, the market all belong to the power generation and all belong to the government. Now we should to change. Now the power market belong to the government and all the private companies. Now we thinking about the income come direct to the customer, direct come to the silent client, and to also they join in the power market. So for this one, the electrical distribution company should to install the e-vehicle charge station in the different parts, maybe in the shopping center, maybe in the university, any place in the public area. So based on that, based on the tariff, they determine, for example, maybe during the time, they have a different, for example, in South Africa, they have a different rate to sell the power or they buy the power from the users. So they can return they can charge the battery during the morning and return to the house, return to the grid through the home or shopping center. In the home, they can minimize their own electrical bill, or in the shopping center, they can return to the grid. So they have the income. It means the users also, the customer also join in the power market. Until now, only they are buying the power from the grid and they pay the electrical bill. Now we want to join the customer also to join with this strategy. So we should to encourage them, we should to share with them the knowledge to how they can join with this strategy. Okay. Okay, this is a type of the electrical station that we have in the Iran at the moment, but the capacity is not high, but still we are working on that. In the MAPNA group is built under the university. So the conclusion is like that. No fuel required, so we can save the money on gas. So for 1 kilowatt hour is only one cent is necessary, is equivalent to $1 is for the gallon for the gas for gasoline. So during the 1 year we can save around 700 in the fuel cost. So this is good for the customer for in the small level also. So we can reduce the cost emission, and we can reduce the CO of emission in the air, because this is one of the challenges at the moment we face on that. Also, low maintenance fee for the electrical vehicle that compare with the traditional vehicle. So the maintenance fee is too much low and better performance than other cars. So thank you so much for attention. This is my presentation. If you have any question, you can.
Thank you very much, Dr. Megami. It was a wonderful presentation, and I can see one hands up. There will be a Q&A session at the end of all the presentations. Okay. So in order to have our time managed in a proper way, so we will take the questions during that time. But anyway, we are very much looking forward to these questions. And before going to the next presentation, let me add up a little bit to the wonderful presentation given by Dr. Megami. Just think about the business model in what Dr. Megami mentioned. Actually, South Africa will be lucky to get Dr. Megami very soon. He will be joining the University of Johannesburg So I'm attracting people from all over the world to South Africa. All these brilliant minds. And but anyway, if you're in India, if you're in Sri Lanka, if you're in Malaysia, Nepal, Bangladesh, or any southern African country, wherever you are, think about the business model at community level, municipality level, national level, where you can plug in the concept into your economy. With that, let me invite our next speaker, Mr. Peter Aldeker. He is the Vice President of Global Business Development and Head of Sales at Cellcube, Austria. And this will be a wonderful presentation, I'm sure, which will give you another side of energy storage systems. Over to you, Peter.
And thank you, Prof, for the opportunity to speak to the group this afternoon. Can everybody see my screen?
Yeah, sure, we can see. Great.
Essentially, dear International Energy Storage Systems Roundtable stakeholders, ladies and gentlemen, fellow South Africans and international colleagues, energy storage believers and friends, good day. Thank you very much for the time this afternoon to outline a brief 19-minute presentation on a specific long-duration energy storage system called the Vanadium Redux flow battery. I have 9 slides which I'm going to share with you, and I'm going to start with the obligatory presentation of the organization itself. I work with an organization out of Austria, in spite of the fact that I have a very South African accent, that is currently the world's largest manufacturer and deployment developer of what is called long-duration energy storage devices that are specifically related to the technology known as Vanadium Redux flow battery. To continue with that particular track, our applicability to this particular group of people is based on the fact that we very clearly come out of a research and development background, and it is in the last 4 years that we've managed to take the technology that was developed in a research and development environment, developed on a very small scale basis, unitized environment, and then in the last 4 years, able to attract enough investment and able to attract the right kind of sizing projects for this technology to become commercial. Basically, what I'm saying, ladies and gentlemen, is that it's in the last 4 years that we have managed to move from a kilowatt sized system to a megawatt and a multi-megawatt hour sized system. I heard from my esteemed colleague who spoke before that the long duration energy storage success story is all about the ability to store gross amounts of energy for the long term, and that is effectively what this particular technology called Vanadium Redux flow battery does. At this moment in time, we have 138 systems running around the world, and we have access to about 45% of those systems on a day-to-day operations and management system. So we can truthfully talk about what the Vanadium Redux flow battery technology has been able to do. And the important element from a technology perspective that it has been able to deliver is cyclability of an excess of 10,000 hours, without any practical degradation in terms of its capacity to hold that long duration energy storage. What does a Vanadium Redux flow battery look like from the outside? They are a configuration of units that are related to what is a very clear sizing and technology that is able to be used these days, called a shipping container. And inside the shipping container is a top power stack, which is where all the cell stacks exist and the pumps. And in the bottom is this massive quantity of vanadium electrolyte. Electrolyte, as you must already know from a vanadium perspective, is made up of 70% water, 15% vanadium, and then 15% either a mixed or a single acid. And the idea behind it is that it is not a solid state battery, but it is a system that is pumped. And it is the poles of the battery which change when one is discharging or charging. So effectively, even though the technology is referred to as a battery, the battery portion really refers to the fact that it is an energy storage device. This is the technology that we manufacture. This is the technology that we install and then operate around the world. And we standardize them between systems that are able to run for 4 hours of constant degradation, 6 hours, 8 hours. And at this moment in time, we are seeing use cases for 12 hours. And in South Africa, we have a system that has been deployed and is already delivering quite successfully multiple cycles a day connected to wind and solar PV on a small scale, commercial and industrial basis. And that is a 13-hour battery. It's a phenomenal piece of kit. Moving down into the last couple of slides that I would like to present before I talk about how this technology can be of particular interest to developing countries, is that this is a technology that is absolutely scalable because of its containerized process. The smallest unit that we manufacture, design, manufacture, and install is 250 kilowatts, 1,000 kilowatt hours. And then the largest unitized system that we manufacture and install is a 500 kilowatt system that is capable of delivering for 4 hours. So that means 2,000 kilowatt hours. And the idea behind it is that this technology is very, very clearly scalable. One of the negative aspects of this technology is that it is not small, although I do question whether that is a negative aspect or not from a technology point of view. In the marketplaces and in the regions where we are working, and those are primarily the countries that are still very much on the development scale. It is not land that is an issue at the end of the day. It is robustness, it is flexibility, it is the ability of a technology that is designed in an environment like Europe, and that technology's ability to survive the very, very high temperatures and the very, very low temperatures that we find in other parts of the world. So with that in mind, I would like to give you a very quick charge and discharge graph to give you an indication of a very specific technical characteristic of the vanadium redox flow battery, and that is that the battery itself has no C rating, no real C rating, and because it can be overrated, it literally means that it is not the power that is important, it is the energy that is important, and metaphorically very much in the same way that a pool of water representing energy could have a number of different pipes in terms of their sizing coming out of that pool of water to draw off that energy. A vanadium redox flow battery, in terms of how its balance of plant has been designed, forms exactly the same metaphorical example, in that if you have a battery that is, for example, a 1 megawatt, 4 megawatt hour system, which is a significant number of our systems at that size, if you have the right inverter attached to that particular system, you can quite comfortably have a 2 megawatt, 4 megawatt hour system, or a 500 kilowatt 4-hour system, effectively changing the use case of that particular battery, both on a charge and a discharge basis. On the discharge basis, I think it becomes appropriate to talk about how the battery is used and the fact that the battery represents agility and flexibility. And on the charge side of that coin, it becomes interesting because when you pair it with a solar PV, I think our eminent colleagues on the call are all very well aware of the shape of a solar PV day, as it were, and that many solar PV plants, if not all of them, are oversized in terms of their design in order to catch as much of that irradiation as possible on a square meter basis. It is that top of the curve that is often a wasted energy. With a flow battery, which has the ability to be overrated, that large amount of energy that has previously been wasted is able to be pushed into a flow battery of this nature, regardless of what the nominal power rating looks like. I think in terms of what this technology has, the potential across developing countries is very much associated to the characteristics of long duration energy storage, which is number one, these systems are incredibly hardworking, and because of the characteristics of the electrolyte, they do not have a limited range of usability. The system can be used between 0 and 100% every day, twice a day, for as long as the battery exists. For as long as the battery exists relates to its longevity, and so far, academically, these batteries are capable of being in operation for longer when it comes to the electrolyte than the actual battery itself will last in terms of its plastic and metals. Currently, the marketplace refers to that cycle life as 25,000 cycles. We have a number of systems in existence that have already been working for longer than 10,000 cycles, and there has not been a material change to that battery's capacity. The flexibility of the system, which is applicable to how we use these systems in harsh environments, is very much related to the ability to change its use case midstream, and very much related to its ability to be overrated. At the end of the day, dear colleagues, this technology is massively gross, is the non-technological term that we use to describe it, because it is not sensitive to temperature, it is not sensitive to the use case. Once it's on the ground, it can be used across a number of different use cases. It can have use cases stacked in it as opposed to one use case. And very, very importantly for the renewable energy environment these days, it makes a very good technology to be co-located with wind and solar. I think in the time that I was granted, and again, I thank you very much to the International Roundtable for Energy Storage Systems, I would like to again thank you very much for your time and bid you a good day. And should you need to engage on further discussions regarding vanadium redox flow battery and how they compare to other long duration technologies, I would be very, very happy to have that conversation. As a last note, and I've left it for last because I believe it is probably the most important characteristic of the vanadium redox flow battery, and that is we have in earlier 2022 managed to project finance a vanadium redox flow battery, and the reason why that is the most important part of a vanadium redox flow battery's characteristics is that it is a clear signal from those organizations that lend money into the renewable energy environment that they are finally accepting that batteries can also be debt funded, and importantly, they are showing their desire to work with long duration energy storage devices as opposed to short duration energy storage devices, which practically speaking are not able to be debt funded because of their short lifespan. And colleagues, thank you very much for your time.
Thank you very much, Peter, for that excellent presentation. And I think those who are listening and with us here today can get a good idea from the first two presentations alone that how fast the world is going forward. How many of you have heard about the vanadium redox flow batteries? And how many of you have thought before that this is an emerging research area, business area, industrial area, and at the end of the day, it is extremely important for many countries, or all the countries in the world, to think about the policies, guidelines, and more importantly, the standards of these newly emerging technologies. So with that, let me invite Prof. Mkulumate to talk about that last point, standards. the need for standards governing energy storage batteries for developing countries. I think this is one of the most important topics that we will be covering today. Over to you, Prof. Mate.
Good afternoon, good day, wherever the audience is located. Is my slide visible?
Yeah, sure. Your slide is visible and we can hear you very well.
Thank you very much, Prof. Combs, and the colleagues from India who are co-organizing, and our local guys from DSI and old friend Peter that we have not seen for a while. And also take the opportunity to thank Dr. Magami for an excellent introduction. I would maybe go over as to why we choose storage. I think the world today indicates to us that it is necessary that we reduce expenses for consumers due to the ongoing world challenges that has seen energy prices soar. And I think the integration of varied power sources with wind and solar, and with the growing success of commercialization of Vanadium Redux flow batteries, is affording us an opportunity that responds to greater energy flexibility and reliability. And Peter mentioned a very important point with regards to the harsh environments where we can find application and deployment of these technologies. And I think more importantly, the last item there with regards to the climate impact. So all the challenges and debates around renewable availability are balanced by the introduction of storage. Most people last knew of me being at CSIR. I'm now with UNISA, the Florida campus, and then I'm part of the Institute for Catalysis and Energy Solutions, where our vision is solving energy problems for tomorrow. The Institute has two focus areas, and the activities are indicated there. And I think from the attendees and the audience, we can simply say we are open for business to collaborate with people that are interested in the areas that we're working on and beyond. In South Africa, we have South African Bureau of Standards, who have the mandate, among others, to develop, promote, and maintain the standards. And I think for the purposes of energy storage standards, we do have a technical committee, TC63, which is primarily formed to establish standardization and testing protocols in the field of energy storage, product, and their integrated management services. And it is important to indicate that all the activities are done with international partnership and collaboration. As you can see that the SABS is part of IEC and ISO. The Industrial Development Corporation of South Africa undertook a study to understand the energy storage landscape for the country. And there on the left under the area, you can see that with regards to bulk energy services, ancillary services, grid infrastructure service, and customer energy management services, those are the areas that were seen as priority. And on the extreme right, it would be the ranges of the megawatts that can be accommodated, also including the duration in terms of minutes and hours. But more importantly, in the middle, when we are experiencing load shedding, it is indicative that we don't have power reliability, so the security of supply is a problem. Unfortunately, the demise has not deteriorated to where we could have to have a black start. So I guess time shifting of energy arbitrage, as indicated on the first column there in the middle, is necessary as we are experiencing load shedding because it's scheduled differently from province to province. Excuse me. And then mention was made of ESCOM, our utility company. On their campus, they do have an energy storage facility where they are looking at the lithium-ion battery with a Redux flow battery from Bushveld Energy and also zinc bromide from Primus Power. And then companies like Eaton, ABB, and others, they do have microgrids that enable continued production and productivity in their manufacturing activities. This is interesting that we are in 2022 and projections are such that by 2025, the African market would be of a revenue of $4 to $5 billion. And a little known fact there is that according to the Arthur D. Little study, the market of battery market is expected to reach about 90 billion by 2025. But more importantly, there are new innovations such as solid state electrolyte lithium batteries that will find application into the market. This is very important because the speaker from DSI indicated the availability of energy storage minerals in Africa or elsewhere in other parts of the developing countries. I would call our attention to midstream where we are talking about the critical gap. Such skills of material purification and refinement and process material and cell manufacturing. From other literature, you'll realize that we have absence or we are very lean on that. And then going downstream, manufacturing, we all are too familiar that most manufacturing happens in China, Europe, Americas. But when you look at Africa, unfortunately, we don't have any manufacturing of such high-tech products. But more importantly, when you're looking at the end of life and secondary use of batteries, it is going to be necessary that we start to develop skills and have pilot projects in recycling and reuse of those materials. So this is something that I think we are all too familiar with regard to the role of energy storage systems. And I'll just call your attention to the middle line where we have fuel energy resources. And then on the extreme end, we have customer energy services. So to an extent that other people may not have access to electricity as yet, we see that to enable access, we would need to have more of distributed generation and energy storage system, leading inadvertently to customer energy services being assured for most people. And when we are talking about developing nations or developing regions, the highlighted areas with regards to, I will do left and right. When you are talking about policy and regulation and looking at the value of storage, I'm not going to be going into all those things that are listed there. But I would say with regards to policy, sometimes it's non-existent, which becomes a problem for introduction of technologies into those developing regions. You'll see later on as to why that is important. With regards to the value of storage, it's always a question of who pays for and who owns the asset. And I think Peter indicated that they have recently funded a project on VRFB. And then with regards to prices, emerging markets are more price sensitive in terms of affordability. So when I indicated that there is a disconnect between the manufacturing and the deployment, you can see that when we are talking about distance between site and supplier, there are travel challenges with regards to how far do you have to go to deliver, and then do you have an infrastructure that would give you access to where you need to do your deployment. And then when we are looking at developing regions, there is lack of data in terms of the supplier. And then when we talk of lack of site appreciation, we would want, or we would desire, an environment that enable ease of doing business such that the people can have access to energy, but also there is a good reason to have business in those areas. And I think with regards to weather, that has been mentioned. So we would have to develop technologies that are robust. Regarding local expertise, that has been said, and then we know about the challenges with Greek monopolies. So this is just a high-level summary of problems in emerging and developing countries. You have your regulation and the current infrastructure, but more importantly, tariffs which respond to affordability. So when you have to do a testing, that is a general protocol that would be followed. The third block there indicate defining testing procedure. By being part of the international or the global standards committees and all, the testing has to be verifiable and repeatable in different countries. And then we know about this, the concerns and mitigation with regards to battery fire. And we can see on the pictorial that it will start with a cell failure leading into a thermal runaway, and then you have a propagation. So with regards to the risk associated with deployment of batteries, you have lack of battery overcurrent and over voltage protection. So those are areas that are opportunities for development. And then the need for improvements in the operating environment with regards to humidity and dust and the installation process. Those are some of the things that are responded to by the standards. So when we are talking and thinking about product battery testing, we have those three hypotheses, and I think the first point is the one that I'll emphasize and maybe go to the last one. Where we lack uniformity in the testing procedure and performance, evaluation of energy storage for stationary application, that becomes a stumbling block in terms of warranties and guarantees of performance. But to close those gaps, to harmonize, we would say we need codes and standards all over to ensure that the energy storage projects are delivered in a manner that is going to ensure that they are able to operate and deliver. So what has the South African Bureau of Standards done? I think the first quotation there is interesting to note that due to increased awareness of energy storage safety, there has been a reported reduction in the fire incidents in the year 2020 to 2021 compared to earlier years. And so it means there is growth in the development of early detection and warning systems. And those are some of the standards with regards to installation of those batteries, your safety requirements. And the last one is important when you're talking about secondary cells and batteries for renewable, because to reconfigure and to change the architecture for stationary storage means that you have to introduce a new battery management system and all the other necessary adjustments. So here are some of the other standards that have been promulgated and are found to apply in the country. So it would be interesting to see that in developing countries, do we have standards making bodies that are able to support the deployment of technologies in an environment that is regulated? And I think some of the standards and regulation entities that we have NRCS, which is the National Regulator for Compulsory Specification. We would note and appreciate that the introduction of electric vehicles in the country meant that there has to be a specification with regards to charging, and then you have your normal testing and electrotechnical in terms of components that are coming into the country. And we all know too well that the National Energy Regulator of South Africa engages with regards to the pricing and the limits of introducing storage in the country, even though lately such limitations have been removed. Now, this is something that is exciting for me because when we are looking at SADC, we have a huge opportunity for setting up business case for battery cell manufacturing and recycling. As you can see, when you're looking at Africa there in the middle, as I'm pointing, if you see my cursor, you have all these countries with the minerals that are needed in batteries. And unfortunately, the processing of the minerals happen outside the country. There could be a value add if the minerals are developed up to where they are precursor materials before taken out of the country, such that there is more valuation. And this would also go to recycling when you are ensuring that the security of supply of materials. So SADC that I referred to, it's a regional economic community of 16 member countries that you see over there. And the known challenges is with electrical connectivity, with a statistic that is disturbing to say about 600 million or so people in Africa or SADC don't have access to, not SADC, Sub-Saharan Africa, SSA, they don't have access to electricity, but there is the Office of Energy and the AU desk that can be used as excellent resources to map up these opportunities. So as I conclude, I would say, quoting Dr. Vanessa Ushi, Africa needs to promote policies that enable the creation of more value for their minerals and all. We need to guide African countries to optimize benefits from the battery and electricity vehicle chain standards. But globally, the lessons for us as Africa and other developing nations is that every nation needs codes and standards for energy storage, which would respond to safety of products in the markets, warranty on performance and durability, and end-of-life recycling, reuse, and repurpose. Thank you.
Thank you very much, Prof. Mate, for the excellent presentation and sticking to the time in a perfect manner. And just the take home of this presentation, as I see, is that there are two important points. One is how much resourceful the developing countries, South Africa, Malaysia, India, Sri Lanka, you take any country, Lesotho, Botswana, all these countries are very resourceful. And over the centuries, we are developing countries because we did not optimize the resources that we have in these countries. Now the new technologies are emerging. At least now we have to think about this point. We have the resources and we should know where, when, and how these resources should be utilized. I think that is one message given by Prof Mate. And the other point is, before we step into the new technologies, think about very seriously how we manage those technologies, and that is where the standards come into play. So over the years, over the decades, we have seen in many countries, many developing countries, that we are thinking about, we are giving thoughts about standards long after we adopt technologies. And when we find that things are going wrong, then suddenly we think about the standards. I mean, if you look at my core field, lightning protection, we see that after century of technological applications adapted by many developing countries, even today there are countries which do not have the proper standards for lightning protection. The same in many other fields. So think about it. And thank you very much, Prof Mate, for the message that you have given. I'm sure that we will get good questions from the audience in this regard. And before calling the next presenter, let me remind you that you can ask questions. You can type the question in the chat box. And apart from that, anybody who want to raise a verbal question, you can raise your hand. I'm sure that all of you know how to raise the hand in the MS team, and then you can ask the question. Thank you very much. And then we are stepping into one of the eminent figures from South Africa, Prof Naidoo. He is a professor of engineering at the University of Johannesburg. He is one of the key figures of Eskom in the yesteryears, and he is one of the most popular researchers and industrialists in South Africa at the moment in the field of energy and power. A role of nuclear power coupled with energy storage technologies in reducing carbon footprint. Prof Naidoo, it's over to you.
Thank you, Chair, and thank you, colleagues. Chair, is my presentation on screen?
Yeah, sure, we can see it very nicely. We can hear you, we can see it.
Thank you, and now you can see me also. Thank you, Chair. Thank you, colleagues, and greetings to all the delegates and to the chairman for the invitation to present a view on the role of nuclear power coupled with energy storage technologies in reducing the carbon footprint. Chair, background. Firstly, let's start with the non-negotiable. We've got to abandon all carbon-based resources of energy, and I think this is a universal expectation, and we all need to deliver to this commitment. Chair, the reason for carbon being so dominant in our space, in our economic space, is that of successive industrial revolutions have brought us to this point. And again, industrial revolutions, particularly in the sectors of electricity and transportation. And again, it's driven by this aspiration to serve the growing world, the growing population, globally and locally. Chair, I have a few observations and then a few comments. First observation. We very much going into a space of what I call organized chaos. As we migrate away from the carbon-based resources, the global trend has been to add more renewables. And again, on balancing the intimacy of renewables, a lot of dependency has gone to, again, carbon-based gas. And again, we have the situation where Russian gas has gone to zero. And again, Europe is returning to coal. And again, the net result being more carbon emissions into the atmosphere. Chair, again, in terms of this revolution that we are seeing in the energy space, we've got a market-based operation that's coming to the forefront. And the market-based operations is again giving us clearly lots of uncertainties that we'll have to deal with in terms of managing the commitments to end customers. We see, for example, in California, we are using alerts to tell our customers to turn off non-essential power, effectively to go easy on the grid itself. And again, we find that this economic impact is translating, firstly, to affordability, and secondly, to the national economy and its workings. Now, Chair, this is coming forward in terms of a second observation, the environmental impact, that of extreme weather conditions. We've seen recently the high levels of swings in global temperatures. You've got one end, China, very hot, very dry. And again, similar situation prevailing in Europe. And again, the Three Gorges hydroelectric power plants stranded. The EDF nucleus also stranded. And the nucleus in France had posted a very low energy availability factor of 42%. You go across to the UK and you look at the offshore wind capability, also in the gigawatt scale, but idling. And then we get recently the challenge in Pakistan. Chair, again, a cautionary note on renewables. And I think we need to all digest this fact that renewables are very much dependent on weather conditions. And given the forecast of extreme weather events due to climate change, we've got to expect and plan for extreme impacts and performance from renewable energy resources. The third observation I'd like to note, Chair, is that of electricity. And again, we class electricity as the most efficient carrier of energy. And that source of electricity emanates from the synchronous generator. So in moving from the conventional grid to the modern grid, we know we need to take the synchronous generator along with us. We cannot leave it behind. The synchronous generator and the wires are inseparable. And again, the synchronous generator works off the principle of electromagnetic induction. Going forward, we need to preserve electricity as the energy carrier for all within the economy. It's got to be delivered at world's lowest cost. It's got to be delivered at 100% availability, and it's got to be delivered at zero disturbances. Chair, and I make this plea especially so, given our migration in terms of the industrial revolutions. We're now in that stage of the fourth industrial revolution, and very soon within the domain of the fifth industrial revolution, all requiring availability with zero disturbances. It's time to reflect, Chair, at this point on the energy fundamentals. And if we get this right, we'll get the others parts of the equations correct. The first fundamental, the source of all energy, is very much the sun. In its real-time characteristic, it comes to us continuously. And again, a recommended global and national strategy is that all of us must invest in the harvesting of the sun's renewable energy potential. From solar to wind to rainfall, we need to bring that into daily application. The second fundamental, Chair, is that energy is neither created nor destroyed. It transforms from one form to another. And again, it's the energy of the sun that we are talking about. And the best way I could represent this, Chair, is that of the periodic table to be the best representation of the stored energy of the sun. We've had lots of experiences with the carbon-based element. We have lots of experiences with the uranium-based element. And again, with hydrogen as a potential energy carrier for mobile loads, we have the experience of both storage in large scale as in pump storage and storage as in large scale as in battery storage. I want to now bring forward the conversation a little bit focused around uranium within the space of energy storage. When we look at uranium as stored energy, Chair, we talk of its availability, affordability, accessibility, and again at national grid scale and at density of scale that is acceptable for national grid operations. Back in South Africa, we have the Koeberg nuclear power station located just outside Cape Town. And when we take its availability numbers, we see that from breaker close to breaker open, the typical time is in this sort of category, 400, 450 days. At load factor unity, energy availability factor, 100%. When we look at the costs of nuclear to the national grid and then to the end customer, we see that over time, nuclear has consistently delivered world's lowest cost electricity to the national grid and to the end customer. And again, that attribute needs to be captured and carried forward as we go into the next phase of the energy revolution. In terms of the waste and the waste disposal from the units itself, we see that from 1984 to date, almost 4 decades of continuous operation at unity load factor, all the spent fuel assemblies continue to remain on site, at scale, at density. There have been zero air emissions, zero environmental disposal of the high-level waste. It's still within the main containment buildings at the reactors of the 2 units at Kubak. Again, the third fundamental I'd like to bring to our attention, Chair, is that energy diversity for economic security. We've got to go into this space where diversity gives us strength. We've got to bring all the clean energy resources into a balanced mix of availability, affordability, and accessibility. If I may just reflect on the events of the last few weeks, we see the disturbances in the UK, and we see the outgoing Prime Minister make this statement regarding their investments into nuclear going forward. They will certainly be promoting deep their developments within the nuclear space itself. And again, they're promoting nuclear so as to assist them in terms of making this migration from fossil fuels towards clean energy resources. In terms of the career going forward, Chair, nuclear offers an opportunity in the science, technology, engineering, and mathematicals field. And again, we are experiencing back in South Africa an avalanche of exit in skills and expertise. They are all heading into the global market for the top paying jobs. So, Chair, in terms of the next steps forward, I think in terms of the reflections, all we need to do is add the numbers, start updating the global and national integrated resource plans, and start growing our scholars on STEM careers going forward. Thank you, Chair.
Thank you very much, Prof Naidoo. And yeah, it was a very thought-provoking presentation. And let me tell you a few words about selection of this topic. Actually, we specifically selected this topic to be included in this event because in the modern world, people are talking a lot about renewable energy. But there are many limitations of this wonderful source of energy. And is nuclear energy dead and gone? This is one question that many people have in their mind, whether it is sustaining or whether it will sustain for the next few decades. So we needed to come up with a presentation where the world will look at it in another eye. So we thought that Prof Naidoo is the ideal person to give this presentation because he is very active in the SAIEE nuclear chapter as well. So thank you very much, Prof Naidoo, for this wonderful presentation. I'm sure that we will get a lot of questions in this regard, and let's look forward to the Q&A session. And with that, we'll go to the next presentation. My colleague, Prof David Dorrell, he's a distinguished professor at the University of the Witwatersrand. And David is going to talk about EVs for developing countries, possibilities and challenges. Actually, this is, again, a very thoughtfully planned presentation because now you see that we have 2 presentations on the mobile applications of energy storage systems, because we feel that this is the future, and the countries should take this very seriously into account, especially the developing world. It's over to you, David.
Thank you very much. Can you see my slides okay?
Yeah, sure,
Absolutely
perfect.
fine.
Right, okay, right. Thank you very much. My name's Dave Dorrell. My presentation won't be that long. I thought this was on Wednesday. I only said yes last week, and I was down at Northwest University doing a research assessment there. I've got an interest in electric vehicles that covers several different areas. If anybody thinks I don't know what I'm talking about when it comes to energy storage and power systems, then I'll claim to be a motors person. I've also got contacts into China, where two of my ex-research students are now professors at Beijing Institute of Technology, that has a huge electric vehicle research institute, probably one of the best in the world. And so I'm still publishing in this area with them, even though they finished a few years ago. Oh, have we got somebody in the background? Right, okay, let's see if I can, right. Sorry, I'm just trying to work out how to change my slides. Right, let's try here. Okay, has that gone on to the second slide, the introduction? If I pull this down here. Oh, still trying to make it move. Right. Okay, right. Can you see the second slide here?
Yeah, we can see it in the slide mode, not in the presentation mode, but it's okay.
Okay, that's fine. I use two monitors and it always seems to get confused when I'm online. But you can see the introduction there.
Sure, we can.
Okay, right. Okay, just to state some obvious facts that electric vehicle numbers are growing in many Western and Asian countries. For those who don't travel outside South Africa much, then if you go to Europe or you go to Asia or you go to North America, you'll start to see a lot of electric vehicles, not just hybrid electric vehicles, but electric vehicles. I've got a house in the UK that I visit quite often, and I'm seeing more and more, and I'm even seeing commercial vehicles. So people bring their company van home and plug it in on the front drive. So what do we mean by electric vehicles? Well, everything from simple scooters, and there's the stand-on type little scooter. And in fact, in York, where I've got my house, the local council has a scheme where you can, there's public electric scooters that are left charging, and then you go onto their app and book it out and can go around York on a scooter. I've never ridden one because I think I might break it. But you also go on to the scooters, which are the sit-on ones, the Lambretta type scooters. If you go to China, you'll see a lot of those. They're very popular. In a lot of Chinese cities, you'll see a lot of electric vehicles and scooters. In China, you've got to actually get the registration for your vehicle before you get your vehicle. And certainly both of my ex-students in Beijing have got electric vehicles, simply because there's no registrations for petrol vehicles initially. The backlog is many years to get one of those. And you can also go through into mopeds and electric cars, SUVs, bakkies, luxury vehicles, and then onto commercial vehicles such as taxis, buses and goods vehicles. So that all these vehicles are appearing on the market in various countries. However, in South Africa, people may feel free to contradict me because I've not noticed, but all I've ever seen of electric vehicles in South Africa are more of the luxury models. So it's a rich person's toy. There are some sales of electric scooters, though not many. And I guess those of you who are golfers might have had electric golf carts. One of the problems may be with electric vehicles in South Africa is energy storage for this charging, because of issues with power system stability and even load shedding. Now, just to go a little bit off topic, more onto my area. So let's look at a typical family saloon type car. I wish I could afford one, but here we've got a Tesla Model 3, and Tesla's come a long way. I remember several years ago going to an American conference where keynote speaker was the a technical guy who developed the first sports car. They actually had a two-seater sports car as their first car. I think Elon Musk pushed him out the door by that stage, but he came along and gave a talk on its development. And at that time, they were using things like I think they used batteries that they got from computer batteries. Were basically what they're using. So lots and lots of small cells, which does give a degree of redundancy. And they were even using an induction motor rather than a permanent magnet motor. Teslas today, they're often coming with two motors, because if you double the power of an inverter, often the price more than doubles. So there is method in the madness of having two motors, because you've got two inverters, and those two inverters are costing less than one inverter, which can handle double the power. Also, the different motors. So you've got a brushless permanent magnet machine, which is designed for efficiency, and that will be used when you're cruising. But there's also an induction motor, which if you turn an induction motor off, all you've got is steel and copper and aluminium, and it will freewheel quite easy, and you can use that for your accelerations. For those who've never driven an electric car, of which that they can be very fast off the line, so a lot of petrol heads actually quite like them because they're very fast. So a modern Tesla will be combining two different types of motor in their vehicle. Now, within the African context, those rare earth magnets are expensive, and the materials nearly all sourced from China. So in an African context, you'd probably want to try and make magnetless motors to reduce the cost of the motor itself, and also go to axial flux machines, which might make them more suitable for electric motorcycles. And I think electric motorcycles in Africa may well have traction. Sorry for the pun. And these are called IPM for internal permanent magnet machines, so they have some saliency. Commonly there'll be about 6 poles, going up to maybe 6,000, or even over double that, depending on the design. The faster you go, the better your gearbox has to be, because you've got quite a big step down. But you'll get up to 96% efficiency from these rare earth permanent magnet machines, and even for an induction motor, they're claiming up to 94%. Although I've been doing designs for those, and that is a tough ask. So if you do axial flux, and I've got a program to start looking at these, you'd look at something like this. So you've got stators and rotors next to each other, and the main flux across the air gap goes in the axial direction, not the radial direction. And there are commercial machines out there, and they are somewhat more compact. A lot of these motors, even with only a very few % losses over a hard acceleration, that can be quite large, and you do fluid cool a lot of these machines. It's a bit strange in that that you have to design for the extremes for the machine, but in reality, the peak torques are really only used during braking. Remember, you've got actual regenerative braking, so unless you drive like a maniac, you actually very rarely use those peak torques. And these machines are actually rated in a transient fashion. They're not steady state rating. The steady state rating is often less than half of the peak torque performance. And Mercedes-Benz have gone and bought these the Yasser machine. I wish I owned that company. I'd be rich now. And they're looking at these actual flux machines for obviously for Mercedes-Benz, but for electric scooters and motorcycles and small cars, these may well be a very good option to go down. And also, if you start looking at the actual flux induction type machine, which I'm doing, they could be cheap to manufacture and suitable for a developing country. So, as I said previously, then South Africa is still at the stage of importing luxury electric vehicles for rich people's playthings, really. But I think with time, you'll start to get more standard type cars imported, and also start looking at other vehicles that may be unique to the African context, like the minibus type taxi, and smaller vehicles for basic transport, such as mopeds and motorbikes. I think these should be emerging. I think the problem at the moment is a lot of the small electric mopeds and scooters are going to struggle in the African context with the rough roads and the need to carry a lot of more load. This isn't all pie in the sky. There is a company, Hala Motors. I don't know if anybody knows anybody from that company. It's gone a little bit quiet on this, but they're envisaging taxis, for electric taxis, that a possibility. Bear in mind, we can all see a lot of these taxis get worked very, very hard. So I'm not sure how the recharging would work. And this artist's impression to me looks like it already comes self-dinted in the side. But we will see if that company goes anywhere. But it certainly would be looking at a vehicle that would be of use in the African context. And there is a company down in Cape Town. I don't know if this is I got this data a year or two ago, so I don't know if things are changing. And they were looking at electric motorcycles and scooters, and they were marketing this range. Well, they've got the expensive one for the motorbike. They've also got a small scooter type vehicle, which aimed at students, they said, for 48,000 Rand, which I think that should be changed to aimed at rich students. And then probably more, which would sell more, is a small deliveries type vehicle as here, which should be very basic and aimed at deliveries, but they're still claiming 30,000 for that. And I think that sort of vehicle may well be more suitable for the urban African environment. And I think something between that and the motorcycle, which was more of a workhorse motorcycle, might be more suitable for the country environment. One of the issues with the current scooters, a lot of them are actually imported from China. They're very cheap. And maybe modified here, but they're designed for urban, lightweight use on good roads. And the feedback I got from a company was that they tend to fall apart very easily in Africa. Also aimed at the luxury market. So what you'd need to look at is designing more for rugged areas, so it can be used in rural areas, and more heavyweight. Now, some of the key points for electric vehicles that would stop them being deployed and is high capital cost. I'd like an electric vehicle, but I think they're expensive. And how can you reduce that cost? Well, you can look at building more basic vehicles for the African market. Also, you've got issues with intermittent power when it comes to charging, and something that I'm working on with one of my ex-students, Shuo, in China, is that their institutes are very interested in looking at battery swapping. So you don't go along and charge your battery, you go along and swap the battery out. Now, something like a scooter, you could almost have handheld energy storage there, which might also help with security. A lot of the value in electric vehicles is in the battery pack. If it was a small scooter, you could take your battery pack with you indoors for more security. So also, if it's a smaller vehicle, you may well be able to charge at home off a standard socket rather than needing a specialist charging station or a specialist charger at home. So I think it should be looked at more is the use of removable batteries from electric vehicles. Another thing that that was pointed out with my work with my Chinese students was if the batteries are removable, then you can actually rent them rather than buy them. So that if you're going back to and forwards to a battery exchange station, once you've got one, you just take it along and you swap it over, and that would reduce the capital costs a lot and move the capital onto the battery owner as a larger business who could probably afford them and get a better deal. Also, if you're doing battery swapping, those can be charged when there is power, so it wouldn't be affected by load shedding. And similarly, if you've got an electric vehicle, can you use that energy storage during load shedding is an issue. Now, I've heard this before, and several years ago, I certainly was in a conference where people were planning on, well, let's use the batteries for smart grids, for energy storage. And somebody pointed out that the batteries in electric vehicles are the Rolls-Royce of batteries. They're expensive. Do you really want to use them for energy storage, for static energy storage rather than for electric vehicles? Because you'll age them a lot quicker. And indeed, a lot of electric vehicle batteries, when they're at the end of their life in a vehicle, get recycled into static storage because there's still plenty of life in them. It's just the energy density has gone below a certain threshold, and use them for static energy storage at home. So these are all questions that need to be addressed, and the answers to these questions will be continuously changing as time goes on. So these swap, and just to show you that this isn't just a theoretic, this isn't just an academic theoretical study. In China, there are some battery swapping stations. Bear in mind, it's such a huge populous country that small projects there would seem like big projects to us. And battery swapping might have the advantage of overcoming any issues with load shedding, since you don't need to store any energy to charge the batteries when the user turns up. They're already recharged. And also you can reduce the customer costs since you can rent them rather than buy them. And for somebody from a modest income, that could make a big difference between having an EV and not having an EV. And also, if you've got decent battery swap way you've got decent ways to swap a battery, then you can swap them a lot quicker than it would do to charge the batteries. And just to show you that these do exist, these systems do exist in China, and in 2020, you can see between 2019 and 2020, the number of vehicles going up that use this sort of system is substantial. So, you know, there's in 2020 there was what over 100,000 vehicles that were using battery swapping as a technique. I think I first saw this on buses when the Beijing Olympics were on. They had electric buses that had battery swap facilities. So the bus had come in, they'd swap the battery, and it was back out on the road again. So it was a good demonstration. And just to show you, you've got two different ways of doing this. You could have a centralized battery charging station, and then you have a various transport, and you transport them out to the battery swap station, which would be a good idea if you don't want to carry much inventory. If that's the sort of system you have, then as people maybe book in for a battery, then it will be delivered, so that the battery swap station does not have to carry a huge store of batteries. And then you could have a micro battery swapping station where they take batteries in, they charge them, and then they put them out on a different vehicle themselves. Being the way that everything seems to be integrated in with renewable energy, then this would be a good way to use intermittent renewable energy. You can charge the batteries when the energy is there, and as long as you've got a stock of them, then that would be fine. And just to show you that these in China, I've got a picture of a Chinese battery swap van that's taken batteries out to a swapping station from a central charging station. So I thought that I'd put that idea out to you in case people hadn't thought about that idea as a way to reduce the cost of electric vehicles, and also a system that to me might be a good system in the African context. Okay, right. Right, thank you. I'll finish there. I thought there'd be questions after each presentation, but I can see there isn't, and it's a Q&A session right at the end.
Thank you very much, Prof. David, for that wonderful presentation. It shaded a good light on this topic. I mean, by summarizing this presentation, let me ask a question, or let me pose a question to the audience. Now, say that if you are from a certain country, say a developing country, let me take Malaysia for an example. If you are planning a vision for the next 10 years on transportation, definitely EVs, electric vehicles, will be your prime mode of transportation. I hope that all of you will agree with me. Now, my question is, are you suggesting your government to go for the infrastructure development for battery storage or battery operated electric vehicles or hydrogen fuel cell based electric vehicles? Think about it. We'll take it up during the Q&A. David, would you like to tell a word?
Okay, no, my phone keeps ringing. Right, I mean, hydrogen vehicles is a good question if you're looking at fuel cells. I did look up recently because it seemed to have gone quiet on fuel cell cars, but there are a few models out there, and I think it's also to do with the technology for fuel cells it's not quite as advanced as battery powered vehicles yet, but it's certainly something to think about. Hydrogen is a clean energy source if you can generate it cleanly, and if you can get fuel cell cars going, then I don't see, you might end up with, either your choice is either an electric vehicle or a hydrogen vehicle, and it's a free choice. But I think the technology is still a bit behind on electric vehicles.
Okay, David, you are inviting for a lot of arguments.
Well, I think we're still at the argument stage on this.
Yes.
I'd like to see more hydrogen vehicles on the market.
Exactly. Actually, that is the point of this question. There are a lot of debate now going on, and we'll see how the audience feel in this regard. Thank you very much for that wonderful presentation, David. Please hold on with us for the Q&A session. And then we are stepping into the next presentation from gray to green energy through technology and policy development on storage systems. This is given by none other than Mrs. Joanne Dean and Mr. Hugo Stewart. And Joanne, or we call her Jo, is the vice chairperson of the energy storage chapter. And she's also representing energy carbon management. She's the president of that in South Africa. And Mr. Hugo is also from the same company. Jo and Hugo, it's over to you. Jo, you're muted. I think now.
I think it's off now. Sorry about that.
Now we can hear you, yeah.
Big foul pause, sorry about that. I'm chatting away. Okay, thank you, Prof. And Chair, it's a great honor to be here. I think listening to everybody's presentations thus far, I'm a little bit intimidated. I think we've heard it all. We just all need to get out there and start doing this and changing South Africa. I think it's been awesome. I come from a very different sort of side of things. I work a lot in the space of lobbying for policy changes, lobbying for enabling of all of these fine things that we've been hearing about, and then also obviously a good solid understanding of the project implementations. So we've taken it more from a view of from the trenches. It's lovely to hear all of the theoretical parts, but sometimes it's very different and it's very refreshing, or maybe it's a very worrying, or maybe it empowers you is to hear from another side. So I'm going to try and share now. Sorry, Prof, I have a PowerPoint that was prepared. And as usual, when you just come to it now, then it doesn't want to come up. And it's doing that with me again. If everybody can just bear with me for 2 seconds, that I'm actually just going to try and share my screen and then share, and then we might get to it. Do you see the screen now? Hi, everybody. Do you see the screen? Is the screen sharing? Can you all see it or not?
Yes, we can see your screen.
Yes. You see the PowerPoint?
Yes.
We can see it.
Okay, thank you very much. Okay, so energy in South Africa. I'm Jo, as Prof Chandima introduced me. I'm Vice Chair of SAIEE. I sit on the Energy Efficiency Corporation and many other bodies, all trying to enable clean energy in some method or methodology into South Africa. I think if we looked at the state, and that's what I was asked to talk on, was the state of renewable energy development in South Africa. We all know the effects of COVID. I don't think we have to belabor it. The new energy economy will be more electrified thanks to what has come and changed in South Africa. Efficient, interconnected. We've heard Prof Pat speak about the emergence and product of a virtuous cycle of policy action and technology innovation, and this momentum is now sustained by lower costs. So in most of the markets, solar PV, wind based on now represent the cheapest available source of the new electricity generation. I think all of our previous speakers have spoken to this, and we know that we're in a dynamic arena now, and we seek international collaboration and competition, and we need to strive to get the in-house entities up to that standard as well. So why is South Africa open for the clean energy business? The socio-economic and infrastructural development, typical of a developing country. We must always see South Africa as a developing country. It remains a country part of the BRICS, and embedded in it is its electricity generation, transmission, and utilization. Right. So it's Africa. South Africa is Africa's largest consumer of energy, and we're also deemed to be the leader. We're supposed to be driving the change and showing the path in the new way. The rising energy demand in South Africa has overwhelmed the existing power generation plants. There's no other way to say it, but we don't have enough power. I think it's publicized enough worldwide for everyone to know that. The other worrying factor, specifically what Prof Pat referred to, is the conventional electricity generation plants are responsible for placing us 13th on the global list of greenhouse gas emitters in the world. And I think that's quite sad. I mean, if you look how small South Africa is compared to the rest of the world, then we really need to have a strong talk about this point here. And in an attempt to mitigate CO2 emissions, we need to meet the national development commitment to COP. So South Africa committed to COP in November of last year, and we need to provide reliable electricity for its people. Many of our people do not have access to cheap and available electricity. They have access, but they maybe cannot afford it. And currently, the status quo in South Africa is we do not have enough energy generation to go around. So we need to be on a fast track to developing private renewable energy sector and delivering to the energy transition. So my biggest take on it is that the wave is here. How do we embrace this wave and ride it? Right. Prof Chindima asked me to talk a little bit about the currently regulatory situation. So if you can think of South Africa, it's no different to any of the other countries emerging into the energy transitions, where you see gradual deregulation coupled. So this in South Africa was driven, and I think proven very much by what we had the auctions, the renewable energy programs. We know that we had the auctions, and we've seen our caps lifted from 10 megawatts to 100 megawatts capacity, and we've seen our president recently announced there is no cap anymore just for registration. So this was a very instrumental change in the regulation, and what opened what I say South Africa for business is that the presidential commitment and amendments to the Schedule 2 of the Electricity Regulation Act of 2006 is what opens us for business. Before that, we were limited. So I don't want to belabor this. I'm sure everybody finds the law and the promulgations very boring, and we just need to know that there's been this big instrumental change, right? So the impact of this deregulation cannot be underestimated. It allows for utility scale private generation, coupled with BESS, for grid stability in both embedded generators and remote generation scenarios, without a rigorous and comprehensive licensing process and very many bars and levels that we have to reach, right? So most importantly, the regulatory process for registration is decoupled from the requirements of the ministerial determination. This was the deal breaker for many projects and for many aspirations in the private sector, that one would have to apply for ministerial determinations from the Minister of Energy, and wide-ranging discretions had to be given by various ministers and nurses. So now we're seeing a freer market, right? So significantly, Schedule 2, governing the increased 100 megawatt capacity of generation facilities, only requires a simplified and non-discretionary registration. So that's the change. Before, you had to have permission. Now you just have to register and prove that you have compliance, right? So that is that's a big shift for South Africa. So the focus on deregulated embedded generation wheeling is wheeling, which is the conveying of electricity at the point where it's consumed. In the definition of wheeling, for this reason, the memorandum refers to consumers. I'm sure Prof is going to share all of these slides, so I don't want to, in essence of time, take you through all of this. But what we need to understand is this deregulated market of South Africa, which is no longer just the embedded generation, but what we see is distributed generation, where your embedded generators are now able to put the power into the grid and be able to service the national grid and service clients that are not based on site, or they can service clients that are based on site, right? So energy storage by base is distinct from generation, right? So South Africa still typifies it. It does not comprise the initial production of electricity at base, as set out in the definition of generation, but merely the storage of electricity. So worldwide, there's this debate on storage and where does storage fit in, but South Africa within NERSA and within its regulatory environment has deemed energy storage as not being generation, right? So energy storage is accordingly exempted from any licensing or registration as a regulated activity on a standalone basis, and by supply by a registered generator to a multiplicity of customers is specifically contemplated by way of reading. So what we now see is the emergence of the IST mobile, where you can have one power plant that will have maybe storage, PV, wind, whichever hybrid, biomass, Prof's nuclear power. You can actually distribute to multiple clients across the grid. Right? The next stages, there's a growing trend in the development of procurement of renewable energy outside the REAP. This is where we're changing. Our municipalities have got the growing ability to procure their own capacity or to buy from private sector. We're busy dealing with public procurement, customer-driven capacity choices, but primarily this is the important shift. There is no longer a monopolistic viewpoint where energy may be only supplied by one entity or only be sold to one entity. So the establishment of the ISTMO would provide a foundation for a market mechanism, further enabling liberalization of the generation capacity growth. So what I'm really trying to say is everybody was banked onto the renewable energy auctions and the bits that can generate to Eskom for the sale to Eskom. We now see independent customers and clients being able to transact with each other in a more deregulated market, right? And this is what we need to future-proof now. And this is where it's important, because this is where the technical discussions need to happen, is what can the grid absorb, how we're going to balance the grid, etc. But we needed to get this mind shift change. What I've spoken to you before might sound terribly boring, and I'll leave you to read the slides at your leisure, but it's been instrumental in saying that everything Energy SA has changed, and it's still changing. So the last 5 years has seen this tremendous exponential change in the energy landscape. Right? And it's a radical mindset, because we're never going to make a difference if we simply follow the pack. So it's still difficult for many to absorb, right? We still have to make that mindset change. There's still very many conversations that you have to internalize and never accept that it cannot be done, right? So we're moving into a new world, and it's a world that makes many nervous. What is the first most important part? The biggest change in the energy project landscape is the boardroom mindset and the banking mindset. These were two most important topics, is that we had to get buy-in from the many entities in South Africa so that they can prove to Prof Pat's very startling, very shaking presentation, where we see we need to decarbonize, we need to make the changes. And these changes aren't being made, they're being driven by ESS, ESG, environmental social governance conversations. Right, so that was the first one. The second one that was very difficult to surpass for South Africa, in which I think we're into that mindset now, is the banking mindset. Because investment into these projects is still critical. The deal breaker to all of these projects has been the inability to obtain investment. Right, so investment was always coupled to the renewable energy program, the auctions, coupled to an Eskom offtake agreement, and coupled to a sovereign guarantee. Now we're seeing the ability of the banks, the commercial banks and private sector investors, equity funds, angel funds, whichever type of funding vehicles, DFIs, your DBs, and that are saying we want to and we embrace investing into the ISTMO private sector IPPs that are going to generate. So this is finally been accepted and endorsed by governments, business, and consumers alike. So this was the biggest. It's here now. If everyone can bid. The second is Eskom is a symptom. We continue to see press reports about Eskom. It doesn't help us to play the blame game with them, especially when the solution is in our hands. So Eskom has its problems, and we need to not throw the good out with the bad. Eskom's got amazing people, amazing assets, it's got transmission assets, and still the backbone is South Africa. Its generation fleet is aging, and it needs to be maintained until we make the transition. And the debt is the problem, but then so is poverty in this country, and the fact that most people are too poor to pay for high price for energy. And Eskom's debt is due to the fact that the population do not pay enough for energy, not because they don't want to, but because they can't afford it. So Eskom faces the classic utility debt spiral, and we need to see how we make that balance and rekindle the energy market or the energy space of South Africa. The third one is we got it here. South Africa's resource heaven. If you have to look at Germany or other places that have made it with half of the energy efficiency that we have wind resources, we have solar resources. We know that the energy industry must reflect on the emerging physical realities of new energy paradigm. Energy systems is a series of dynamic, integrated, distributed energy markets. This is where we're moving on to, and it's not that difficult transition. We're here. Some parts of South Africa have gone to decentralized, and this is where we're moving to with the distributed generation, which would then enhance and still support the Eskom transmission grid, but enable private sector generation. So the fourth, the elephant in the room, people talk about as base load. I think we're not supposed to say that. This is the heavy lifting bit. We can't leave it up to Eskom to keep the lights on from 6 to 8 in the morning before the sun comes up, or 5 to 9 at night when the sun goes down. We can't expect Eskom to ignore their standard generation assets at midday. The mid-meriting capacity plants are very expensive, so we need storage. And this is where the technology makes all the difference. Now, I'm not talking about pumped storage and complex hydrogen and gas and natural projects. That will come, but they're way off. They need the development. I'm talking about the simple, humble energy storage, whether it's lithium or vanadium free flow, technologies that are already available, that have already proved themselves worthwhile. They will enable the transition now, so that we can then move on in a series of years into a pumped storage and hydrogen accepted world. But for now, we don't have this. We cannot make the transition of the Eskom grid without this. So why storage? Basically because it's here now. What do the electricity customers in South Africa want? They want uninterrupted, continuous and reliable supply. They want lowest cost electricity. They want energy options, and they want freedom to exercise their options. They want cleaner energy supply with the least impact on climate change. So energy storage is that enabler, right? And fifth, before I belabor you anymore, we'll hear from Hugo, who's going to tell you how we're going to do this. Is that the cost of technology is dropping. I'm sure we all know the levelized cost of electricity is way below the standard or the lowest tariff on the Eskom grid. So there's no excuse why every single heavy industry CNI projects do not have storage. In fact, no project should be allowed to the grid without storage, because we are going to get to a point where they're going to say we have too much of the variable energy and we need to implement the storage. So my slide that I wanted to explain to you was, these are the myths. These are the narratives that we hear in South Africa. Can it be financed? It can't be financed. Yes, it can. Is it economically viable? No, it's not. It's still too expensive. We can prove it to you. Yes, it is. It can be economically viable. Will it contribute to the just energy transition and the decarbonization goals for ESG? Yes, it will. We don't have any other choice. We need to make that transition to the clean energy. So can it? Yes, to every one of those questions, because these are the deal breakers for the South African market. The biggest driver is, as I said to you, we've had load shedding. Load shedding in 2021 was the worst in record, right? 1,165 hours, 1.8 terawatt hours of unserved energy, uncomfortably close to the total electricity demand. We've got serious problems here, right? As the reliability of the existing fleet continues to decline, delays in procuring, not getting new capacity connected to the grid, South Africa now faces the very, very real prospect of level 6 and level 7 load shedding. So the crisis is here, and it's this crisis on the heels of the COVID crisis that's going to drive this new generation. My last slide is to say to you, saving SA and Eskom. Okay, empirical evidence demonstrates that we need here, as we stand today, an additional 5 gigawatts of renewable energy capacity and 2 gigawatts of storage. That would have essentially saved the load shedding in 21. That's before we're predicting and enhancing for new loads and to local economic development, because there are companies that are thwarted from establishing. We're losing business in South Africa. This power generation coming from private sector. So we can say that it's cost saving. I'll leave these slides with you. I'll share them with Prof. But OCGTs, what does it run cost in South African rand to run? What does coal power cost? What are we seeing renewables costing? Net annual savings to Eskom, what it would change if we did, and this equates to 100% premium of the cost of running OCGTs. So we really can make that business case of 5 gigawatts of variable energy and 2 gigawatts of storage actually work for South Africa and save Eskom 2.5 billion. Eskom poverty is the truth. We have an energy poverty trap. So we've spoken about that we're borrowing from the future, right? We're running OCGTs and water levels and pump storage to meet the demand on a particular day, but without being able to adequately replenish these reserves for the next day, the system becomes more constrained, less capable to meet the demand before. So load shedding is the safety valve, right? In addition to being short of energy and generating capacity, Eskom is also chronically short of cash. Adverse regulatory decisions, the toll of state capture, and unsustainable debt have left the utility struggling to make ends meet. And this has made energy less and less affordable for the poor sector, less attainable. And so we see the growth of not only energy poverty, but also poverty. This just shows you the decline of energy available to our grid. And after all that sad news, we want to understand what can we do. And what I wanted everyone to think about is, let's imagine, right? Let's imagine we have wall-to-wall renewable energy projects, clean energy and storage, right? All in an IPP form. What would it look like and what do we need? So I said to you, I want to talk to you from the trenches. So I've invited one of my most trusted colleagues in the energy space in South Africa. So I deemed this from the horse's mouth. And I would like to present to you Mr. Hugo Stewart. Right, he is going to talk with confidence on this space because I've painted the picture of what we need, but some people are still saying, but can we do it, right? So why I've chosen Hugo to speak to you is because he works across the board. He works as bankers, DD and lenders engineers. He works in the solar and base space as an EPC and as an EPCM. He's phenomenal on UPS systems, earthing design, testing, the actual modeling of these projects, MV and LV design, system installation and commission, and then obviously operation and maintenance of PV plus base, new markets in South Africa. So Hugo, I hope you haven't left me down. I hope you're here and that you can put your speaker on and your camera and that you can take on with the next slide.
Good afternoon, everyone. Joe, thank you for that elaborate introduction. I hope I can make you proud. Yeah, the presentation from here on is going to touch on two things. It's going to touch on unserved energy and obviously on battery storage opportunities and where it fits into the South African market. I'm going to just give you a brief example from some early stats from the IPP office that I got from Joe, and then a quick wind farm example, solar farm example, and then some of the challenge when it comes to the policy and also opportunities. Where there's challenges, there's opportunities. A brief discussion on BESS, and then what I perceive to be a way forward to ensure that the opportunities out there are realized. Next one. Next slide, Joe. Okay. All right, so in 2020, the IPP office indicated there's about 450 of unserved energy from about 80 projects. And recently, it's identified that it's roughly 780 megawatts. And that is a lot of energy if you think about the size of the solar farms. That will be more than 7 or 8 solar farms. And the thing is that these things are already installed. So just to give you some examples, firstly, a wind farm example. I've next slide, Joe. Joe?
It's up.
So I've recently had to do technical due diligence on some wind farms, and this is now just a typical example of where the opportunity lies for unserved energy that could be utilized in the network. So these two wind farms use this SWT 2.3 megawatt wind turbine generators, The one has got installed design capacity of 110.4. It's got a contracted capacity of 107. And then each of them has an overboost function. So each of those generators can be pushed up to 2.4. The other wind farm, similarly, 140 megawatt contract, it's 136.7, same turbines. Also, each one with the overboost function. And these could be set up quite quickly. So there is energy there that's available, but that's not used because the contracted value with Eskom is the lesser amount of the one that is indicated on the picture. Then next slide, Joe. So once again, 2 solar farms. These solar farms will be in operation for about 6 years, if not more. And obviously, everyone knows our panels have improved since in the last year, let alone in the last 7 or 8 years. So next slide, Joe. So these are now poly panels. They were installed as 275 poly panels. So what's happening, these panels fail due to hotspots, lightning damage, whatever. Now you can't find a 275 watt panel, so they all get replaced with 335 watt panels, and the tables repacked. So suddenly you're increasing the size of the solar farm by just the fact that you're replacing broken panels with new panels. And this happens with all panels. All solar farms have a replacement percentage of panels that get changed every year. This is not a unique situation for these 2 solar farms. So next one. Everyone knows that solar inverters have to comply to the grid code, so they have to do reactive power compensation from plus or minus 5% from unity. So when they do their retech testing, many of them have had to take a temporary relaxation and had reactive power installed. But the reality of the fact is, in the number of times I've done due diligence on the solar farms, I've never utilized this reactive power compensation from their filter banks. It's never been called upon to do reactive power compensation for where they are in the Northern Cape and the Free State, wherever they might be. So what it means is that all of those inverters, if they run at unity power factor, can push out more energy than what the contracted value is. So if you put all of that together, you understand why there's 780 megawatt of solar farm of unserved energy, because it's not contracted. That energy is available now. What it needs is a policy framework so that can be realized, because there are challenges. Next, yeah. So clearly you would have to establish a new tariff. Every time a renewable farm is refinanced, there is new contracted tariffs. So in this case, you would need to establish a new tariff for that over and above the contracted energy. And that is not something that is that's needed. Obviously, you're sweating the assets. So you would have to allow for the fact that there's an additional O&M component that the owner of the IPP needs to be able to recover. And then obviously we know that many of our solar farms are in areas where there's grid evacuation issues. So that is something that needs to be addressed. And once again, it's something that touches on the issue of storage. It goes without saying that they would have to, for this new contracted value, they still have to be grid cloud compliant. And then also the issue what happens with these, I just wanted to mention the user responsibility issue of what you do with these replaced panels. Because many of these panels, because you will find that many of the solar farms would go to the point of just replacing their panels with later newer bifacial monoPERC panels, or whatever the case might be. what to do with these panels that aren't broken. Now, on the next slide, we don't have, I can't play the video clip on the next slide, but for any of you who want to look at, there's a company in Cape Town called Circular Solar Project. They're a consortium in Khayelitsha, and what they do is they repurpose solar panels that have been taken and replaced, and they repurpose them for the communities. The same can happen with batteries, and this is a wonderful way of including the communities. We're always talking about what we're going to do with the people that are left behind in the solar revolution. This is one way of including people in the communities as part of ED and SED spend. Doesn't only have to be one place in Cape Town. I know there are other initiatives like this, but this is definitely something that that should be elaborated, that should be extended and grown in all areas of our country. So there's a YouTube clip. Anyone can go and find it, and you'll be able to see how they're repurposing these old solar panels and how it's affected small businesses in the area that otherwise would have been affected by load shedding. Okay, next slide. So
I did show a little bit of the clip, Hugo. So I think
yes,
I don't know if the audience saw it. Yeah. Okay, but I will pass this presentation on to everybody later. Okay, next one. There you go.
Okay, just quickly, as Joe mentioned, straightforward lithium ion or its derivatives, LFP. So that's a typical portion of a utility scale BESS system. Next one, please, Joe. Next slide, Joe.
It's on.
Oh. All right. So clearly what we know is when a grid is constrained, like the South African grid is, you have dynamic stability problems. And these usually end up being frequency stability and voltage stability. And this is the area where batteries come in their own. If the frequency goes too low, the battery discharges. When the frequency runs too high, the battery charges. That's how you do frequency shifting and so frequency stability. And similarly, we know that batteries can be discharged into peak periods and charged during off-peak periods. So together with the problem of not having enough generation right now, Joe mentioned that there are so many new projects that are coming on board, but most of them are a long way away. But the smaller projects can make a big difference. And this is where they can make a difference. Next one. Yeah, just again, a large BESS system. Just to mention, yeah, we're quite involved with a company called Nidec from France. They do the large BESS systems, but there are others around. Next slide. So for those that are not aware, that you use time of use tariff to shape behavior, and the other way of shaping behavior is to utilize the time of use through a battery storage system. Whereas typically a generator you would only use when you have load shedding. The new paradigm for batteries is that you can use them every single day, and you can make them pay off your hard-earned asset. So every morning and every evening during your peak time, you either charge your battery with solar or with off-grid, and then you discharge them during the peak times. And that way you also, so not just voltage regulation, frequency regulation, but load leveling, load shifting can be done with the battery system. The next slide. This is a load profile from the city power that we got from Paul Vermeulen. And Paul indicated that with 350 megawatt of solar and 250 megawatt battery inverters, he could level the city power's load profile. And typically what you would have on the bottom part of that graph, you'd have the green, the solar charges during the day, and the batteries would discharge during the morning and the evening peak. And what it does do is on the top half of the graph, where you have your before battery load profile, showing the typical 2 peaks, you end up with a light brown peak at the top, which is a flat load profile. So the owner of the BESS system would benefit. You compensated for injecting into the grid when it's required. And the city of Joburg's bill to Eskom is reduced because they also pay for maximum demand prices. And then the last one. So in terms of the way forward for now, there's 780 megawatt of power that can be released if the IPP office can come up with a proposal to the IPPs to convince them or to entice them to utilize their spare capacity to install large BESS systems at their existing sites, so that we can have that now and not have to run Eskom's open cycle gas turbines. And 780, even if you realize half of that, that's a lot of generators that you won't need to run. And then, yeah, the story about BESS is out there. I know it's a challenge at the moment. The war in Ukraine is not helping the availability of BESS systems for countries like South Africa, so far away from where they have manufactured. But still, it is a green energy for the country that we are forced to do. But when I say forced, we're forced in a nice way, because we are driven into a green economy because out of necessity. And that's essentially the end of my presentation.
Thank you very much,
Thank you very much,
Hugo.
That was awesome. And I think that we just want to close and leave those words. I actually loved what you said there. We forced. I think that was the best statement that I've heard all day is to get that thinking, because what we're saying all the time is we're finding, I can say, problems to all the solutions instead of solutions to the problems. But we're instrumentally saying here is that there are solutions here now. We need to embrace them and see how we can unlock them and take this path. And it's guys on the ground like Hugo that are making these projects work, that are feathering out all of the things that could go wrong, fixing all the things that could go wrong and make them all go right. So that was very well done. Thank you, Hugo.
Thank you very much, both of you, for the wonderful presentation. And although we are just behind the timing, I can't refrain from making this statement. Now, for those who are listening, please understand that it's not only the manufacturing stage that you have the business opportunities. You see that even the repurposing, disposal, the waste management, all these stages are huge business opportunities. Think about that. And with that, let me introduce our last speaker. She is from USA. She's from the biggest high voltage electrical company in the world, EPRI. Please welcome Ms. Eva Gado. I'm sorry if I'm pronouncing your name wrong, Eva. She will be talking about the role of EPRI actually in the global aspects. And over to you, Eva. Without I'm going into much more details, let me ask you to tell what you have to say.
Thank you very much. So, and you can hear me, John, correct?
Sure, very well.
Very good. Thank you so much. And you can see the screen too.
Yes, no problem.
Excellent. Thank you so much. So I'm going to introduce myself, Eva Gardo. I will also introduce the Electric Power Research Institute, also known as EPRI. And then I will share with you the work that we do in energy storage and research and tools that can make the transition for South Africa and area countries adopt energy storage. So I think an interesting thing is EPRI has just had its 50th anniversary. It was started in 1972, and it came out of a big blackout in 1968 in New York City. And there was a recognition that research needed to be done for the utilities, and they chose a collaborative research model. So EPRI is a 5013C, which is a US tax code for a not-for-profit. So we have a public benefit mission. So just to give a little introduction, as I said, my name is Eva Gardo. I worked for an electric utility for 25 years before coming to EPRI, and I've been at EPRI for about 3.5 years now. Prior to working in energy storage, I worked in the solar industry, and my first job out of college, out of university, was in the nuclear business. So it was really great to hear a lot of these presentations on how the different technologies can help meet the needs of South African area countries. So EPRI, as I said, we are a public benefit company. We have offices, several in the United States, but we also have an office in Dublin. We're looking to start one in Southeast Asia, and we have people in our home offices all over the world. And I would like to introduce Barry McCall. He is our South African representative, and he is on the line to, learning about all these presentations. But EPRI's mission is to advance safe, reliable, affordable, and clean energy for society through global collaboration, science, technology, innovation, and applied research. And we have about 400 entities in 40 different countries participating in the research. We engage with the utilities, academia, OEMs, regulators, and also with national research laboratories and offices. We also get input from policymakers, the financial community, consumer advocates, and the media. We have over 64 research programs, of which energy storage is one of them. And this presentation, similar to what Joe was saying, we will share this in a PDF, and these links will be active so that you can go to the EPRI.com website. Our purpose right now is to reimagine the future energy system, as many of you have spoken or heard from the previous speakers. We are looking to decarbonize our energy landscape to make it clean, affordable, and reliable. And we basically have a two-part plan to what we're going to do in the next 10 to 15 years, and then really where we need to be soon after. So it's really about having reliability, resiliency, and to transform our carbon-based energy landscape into a renewable and clean landscape. And one of the things that really can make a difference here is energy storage. And we've had some discussions on the energy storage options. There's basically short to long duration storage. We have flywheels, lithium-ion batteries, flow batteries, mechanical, gravitational, thermal, and chemical, and of course, hydrogen. So I think energy storage is kind of a really interesting term. I mean, it's really a chameleon and can be so many different things. And one of my favorite really anecdotes is I want you to go out and buy a box. And when you go out to buy that box, it'd be really interesting to see what you would bring back. Because essentially energy storage is the same kind of thing. It can be, small energy bits, or long-term seasonal energy storage. And so it can be used in many ways to support this energy transition. And we've had a number of discussions about how energy storage can really unlock the renewable potential. And this really gives you an understanding of the affordability of solar, wind, and now energy storage, with the ability for more and more people to really take advantage of having reliable and resilient energy, because it is becoming more affordable. But there's still a ways to go. So this kind of gives you an idea of the maturity of energy storage, the different technologies. Pumped storage has been around for a long time, as has lead acid. And there's a lot of developing technologies with flow batteries, thermal storage, gravity-based storage, of course, hydrogen, and supercapacitors. And it's going to take time, money, and energy to get these commercialized and deployed for everyday use. But we're quite fortunate that the transportation and the consumer products industry really has helped make lithium ion really quite a mature technology. And it is really the workhorse of the industry when it comes to energy storage. Once you get past the pump storage. Pump storage, of course, is still the largest in the world. I think we had an earlier graph on the expected use of energy storage. This is a global look, but it's a real critical time for ensuring safe, reliable, cost-effective energy storage systems. And that's really one of the things that EPRI is really focused on, is to get down into the weeds and understand the needs in order to be able to make it safe, reliable, cost-effective. And so what we do within our research activities is we've sliced and diced the research needed for energy storage, and we've put it into these 6 buckets. Kind of an overview of strategic intelligence and industry collaboration. We work on understanding the technologies and the developing technologies and the analytics and the analysis needed to be able to understand how best to use it and where to deploy it to meet the services and the applications that are needed, not only for the distribution systems and the transmission systems, but for the individual customers. And then we have some specific research on distribution system applications, transmission applications, customer, and then of course in microgrids and coupling them in hybrid systems with distributed generation. One of the things we realized a couple of years ago is that we really had to pull together our utility members and our experts and work to understand specifically what research gaps there were. So we developed an energy storage roadmap. And so this graphic on the right with our 5 pillars of safety, electricity, reliability, economics, environmental responsibility, and innovation were the visions that we developed through many facilitated meetings. And we issued our energy storage roadmap 2 years ago. It's called the EPRI Energy Storage Roadmap Vision for 2025, and there will be an active link. This is a free download for anyone who's interested in seeing it. And then we just recently updated that with more details on, what those gaps are, the research that we're doing, and the research that we need to do. And this column on the left basically addresses all the different aspects of energy storage, from the analysis, the implementation, how to manage the asset, what are the skills that the workforce needs, and what are those leading practices in order to be able to have a consistent approach to managing and using fleets of energy storage. So I wanted to share with you that this information, we have a central location on EPRI's Energy Storage Wiki that is open to the public. When you get into this site, and the link is in the blue box, we do have both free publicly available information as well as some information behind the paywall. It will obviously tell you if you need to fund it, but there is a lot of information that is free for your use to be able to advance energy storage in your communities. So as I mentioned, you can get to the roadmap here. We have some analysis tools, which I'll talk to you about in a minute, that are free for download. We have some basic Energy Storage 101 content and courses that you can access here. And then there's also the failure event database, which is available and free to the public, and I'll talk a little more about that in a bit. So this describes some of the targeted research that we have, to address fire prevention and mitigation, performance and reliability, testing and demonstrations that we do and have done, and then analysis. So one of the projects that I was pleased to manage a couple of years ago was our energy storage site-specific analysis project, and we had utility members from all over the country, and then ESCOM also was a participant. And this report is also free and available to the public, and there are case studies on several of the utilities that applied the analysis methodology that has been developed, including one from ESCOM. So please take the time to download this report and learn how you can then do the analysis to be able to deploy energy storage in an appropriate place. So one of the things I wanted to share is this is some of the vendors and the landscape of the vendors around the world, and that we have worked with both specifically individually, as well as just keeping up and understanding their development so that we can share it with our utility members. And what's really interesting is that it's such an interesting time for the industry that people that worked for EPRI have now moved on, have gone to Intel, and we had one of our researchers went to CM Blue, which is based in Germany. EOS is a zinc-based technology, which is in New Jersey, which is about a half an hour from where I live. I live just outside of New York City. So we just work to keep up with understanding these different companies. And one of the programs that we have is called Incubate Energy Labs. And this is an organization within EPRI that works with all kinds of different technologies, but we have had several energy storage companies, and we have an annual demonstration in a cohort of about 20 to 25 vendors. This company, Electric Air, is based in Seattle, Washington, and they are working to develop an energy storage system in order to support fast charging of electric vehicles. But what I wanted to mention here is the link that's on this page. You can go and see about all of the current projects and the demonstrations, and we finish in October, so we're about ready to put our final reports. But you can look at the last couple of year cohorts, and each one of them has a report that is downloadable and free for you to learn about. The other interesting project that we're working on this year in Incubate Energy that I'm a subject matter expert for is a gravitational energy storage technology where they take inactive oil wells and basically retrofit them to make a gravity well to drop and lift a weight that is can be aggregated to have a large energy storage size system to be able to help manage renewables on the transmission system. So we also have, services that we're working with, demonstration and pilot projects, some that I just spoke of. We have a testing facility also in Denver, Colorado, right near the airport. We do technology transfer workshops and training. And we are developing a energy storage deployment playbook, tailored for utilities to guide them through the execution of energy storage projects. But here, I think this is something that's probably really worked to provide you with some good information, and that is the industry collaboration that we do through the Energy Storage Integration Council. In 2013, we realized that basically energy storage was the wild, wild west, and we needed to bring order to it. So EPRI worked with the Department of Energy and with some of the national labs to bring an open collaborative research activity to develop publicly free and publicly available tools and guides for storage deployment. This is an organization that you could join just by emailing esic@epri.com. We have several different working groups that I'll talk to you about in a moment. But the other publicly and free tool that we have is DERVET, which is this Distributed Energy Resources Value Estimation tool. Basically, it is an optimization platform, and you can go either through the storage wiki link that I showed you earlier or directly to dervet.com. You can download the tool, and there are also YouTube videos to show you how to use it. We've used this for energy storage to really understand the sizing of it, the dispatch, charge and discharge profiles of it, and then you can compare it with other traditional solutions to be able to then determine your cost benefit, and it can also give you an NPV, a net present value analysis. So it is a techno-economic analysis tool, and it really helps you understand your project. It can evaluate, various perspectives from, a customer deployment application through distribution to a transmission. So it's a very flexible tool. It started out as the energy storage value estimation tool, and then we've added in so that you can do hybrid solar systems. We are now in the process of combining it with hydro, because we're doing an evaluation to add a battery energy storage system to a hydro plant in order to optimize the runners and the use of the generators so that you don't overuse the turbines, in order to help manage maintenance. So there's lots of different ways to be able to use this tool. All right, so I mentioned the Energy Storage Integration Council, ESSIC, and I have quite a bit of information here about it, but there are, at the specific level, we have task forces, which are really, product publication focus. We have working groups that address specific topics, and then we have general meetings, and we're actually having one in Austin, Texas, the 3rd week of September, if anyone happens to be in Texas. That one will be in person, but many of these other meetings are webinar based, so that you can join and learn. We have a very active one on the DERVET tool to help understand the nuanced use of that. But essentially, the intent was to identify the common approaches and to work to publish the guidelines and tools in order to advance the use of energy storage much more quickly than leaving it as the wild, wild west. So some of the tools here, we have the implementation guide. It describes the energy storage project lifecycle, which Professor Naidoo was discussing earlier. The planning, the procurement, deployment, operation, and then decommissioning. What do you do at the end of life? Do you recycle or dispose or reuse? So that is a very useful tool, but here is your complete list of the publicly available tools. If you go to the